Hello, everyone. Hi, good afternoon, good evening, good morning, depending on which part of the world you're joining from. Let me go and quickly check across platforms if I'm audible. By the way, if you can see me, please feel free to put across in the comments that I'm visible. Yeah, I could see myself, I could hear myself, so I'm open in one of the tabs. Just let me go and figure that out in a minute. I see a hi from Nathan. Hi, Nathan. Good to see you here. Yep. Okay. Awesome. Cool. Thanks a lot for joining in, folks. A quick question. How many of you already know about Pathway? Maybe a show of hands or something like a comment to help you understand if this is the first time you are hearing about Pathway. It's not the first time when we are interacting with the audience at IIT Guwahati. In fact, we've been associated with various IITs in India, and Guwahati being one of the early ones. After I think we first collaborated with IIT Bombay in India, and then the next one was IIT Guwahati. So yeah, the relationship goes long, long, long ago. Um, Let me just check if you're live on both the platforms. I see comments on one of those. Okay, just give me a second. Yep. Okay, cool. So let me start sharing my screen and I'll give you a walkthrough of what it is. Okay, and the idea is okay. I'll I'll try to give you an understanding of what RAG is, what we're trying to do here, what's the utility of it, how you can use it for making an impact or something on those lines. Okay. I see I made some last minute formatting changes, which has broken a few formats, but that's fine. Okay. Let me just share my screen. We'll get into the details, like we'll get into the learning side of things. And I think these things can be figured out. Okay. Okay, I'll share my entire screen and I'll put a few apps. So there's no distraction that way. Think okay. Yep. Cool. Okay. So first of all, thanks a lot for joining in. This is a special session which is organized as a part of the Summer Analytics Bootcamp. And the idea is that we'll introduce you to RAG, which is Retrieval Augmented Generation. Okay. And before that, a quick introduction for Pathway, for those of you who do not know. For me, like I come from the Indian ecosystem, so the way I used to define Pathway used to be like a group of really cool coders, typically what we call as red coders, which means like 7-star coders on Code Forces, Code Chef, and the likes of it, ICPC World Finalists. It's a research company, like almost barring 3-4 people, everybody is at least a PhD or postdoc. Some really cool folks driving some interesting impact. And what is the impact? The impact is like it's all centered around keeping like coupling AI with fresh data and enabling AI applications to learn like we humans do, which is in real time. For example, let's say if you take the example of ChatGPT, which is a very popular tool. I'm sure all of you would have known about it for now, like by now. And if you know, it is trained on a massive corpus of data, but that data is static. Like it's not the real world data is changing continuously, but the data on which the LLMs are trained on, LLMs like ChatGPT are trained on, they are like a bit outdated. So using something like Pathway can enable you to solve that. In fact, if you look at something like Google Maps or ETA prediction, Pathway is very commonly used there. For ETA prediction, it's used across some very fancy use cases, including the likes of Formula One, NATO. Some cool companies use it. It's being used in the Paris Olympics as we talk about it, like in certain use cases here and there. So yeah, it's a powerful framework that way. You can go and check it out on the GitHub of Pathway. This particular session and the sessions that we do in general is kind of inclined with our endeavor of providing high quality education to all of you so that you benefit from it. Okay. One second. Let me just check on screen. Yeah, fair enough. This is happening perfectly. I don't see any comments here. If any doubts, any comments, you can put it across so I'll know. Okay. So first thing, we've all heard about these tools for a while now, like LangChain, Pathway, Llama 3.1. was very much in news. Then there came this new model by Mistral also, this Llama Index, Embed Chain, Mem0, Face, Google Drive, Olama, Gemini Pro, and whatnot. And all of this is like slightly overwhelming, could be, because it's like it seems like a lot of things are happening, but what is it exactly? That is something that we'll try to decipher some of these elements. Okay, so generative AI, first let's understand it. It's like, yeah, we get it. It's about, you know, rather than simply classifying or analyzing a data to give a new prediction, we are talking about generating some new stuff. That new stuff can be text, it can be code, it can be image, it can be anything, right? And the idea is like, if you look at it, generative AI, we feel that okay, we now see things like GPT-4 or Llama 3 and all. But if you look at it, generative AI has been there for a while, like, because we were hearing about things like deep fakes for a while now, right? It's not that it came when ChatGPT came into picture. No, deepfakes have been there for a while. We've been talking about their disadvantages and risks for a while now, and they're based on this interesting architecture called as GANs, um, which had a very simple, like, that is not the focus here, but it had this very simple kind of structure where you would have a generator and a discriminator, which would typically see, okay, fair enough, are you kind of generating what it should be, and is it aligning with what the ideal output should be? If it is not, then you will go back and kind of adjust the weights and come up with a better output. So this is something which has been there for a while. This is how the images based, like, models used to work around generation. That is how video deepfakes, we have been seeing something on these lines. But then what changed? It all changed with this interesting paper that came out, which is called Attention is All You Need, which introduced this interesting thing called as transformer architecture. Okay, I don't know how many of you know about it, but it really made things a lot better, because it enabled researchers to now train these models on practically much larger amount of data. They could add a lot more layers. They could train on lot more amount of data and make the models a lot more powerful. Interestingly, by the way, a small trivia: someone like Lukash Kaiser is also is he's a co-creator of ChatGPT, inventor of Transformer. He's also a part of Pathway as an advisor. He's right now senior researcher at OpenAI. But yeah, we've had a couple of Indians, like, most places we've made an impact. We've seen people like Ashish Vaswani, Nikki Parmar made an impact there. But that's a separate discussion altogether. Circling back to transformer architecture and attention mechanism, it really enabled us to look beyond the realms that we were looking at. And what it gave us was something like the LLMs, large language models. So, for those of you who do not know, the GPT is a large language model. Like, ChatGPT is an application, right? It's like you pick any application. That's like, for example, Google Maps is an application. That's not a model. Models are behind it. Similarly, when you look at ChatGPT, the GPT is the LLM behind ChatGPT. Like, if you go on any LLM right now, you can actually go and select which model do you want to use: GPT-4o, GPT 3.5 Turbo, and whatever, depending on whether you have ChatGPT paid subscription or the free one. Using Gemini, then you would know that there are multiple Gemini models. Even there, I think there's an option of upgrading and all. So, and these large language models could do a lot of things, like, it could work with a lot of amount of input data. They were trained on a huge amount of input data. This input data included both the widely publicly available internet data and also licensed data. So they went a bit beyond, and they also tried to procure data from vendors out there and train these models to become really powerful, to be very well versed with a lot of things. And now with one model, you could do a lot of things. You could do information, like, traditionally, if you look at it, when I started building projects around this domain, we used to have separate models for separate tasks. Like, okay, want to summarize things, there's a summarizer API or summarizer model that we'll use. But now you can do, and for translation you have a different API or different model. Now you see a lot of these things which are like, can be done with LLM itself, and that really accelerated things. And in fact, thing is that these models, LLMs, are actually better at a lot of tasks as compared to previous models. And it kind of, opened a huge spectrum of advantage. Like, now you had these models which were trained on a massive scale of data, which were way more powerful. You could leverage something called as transfer learning and in context learning, which meant that, like, let's say it knows how to play. Let's transfer learning in very simply said, it's like, if you know how to play cricket, the assumption is that, yeah, with some things it might be easy for you to understand how to play baseball as well. Or if you know how to play T20, you can play Test cricket, something on those lines. In context learning, like, LLMs are so good at understanding the context you give to it. For example, if you say, okay, tell me, is the bank open today? Or what is the color of apple? So it will say, okay, the apple can be in red, yellow, green. But then you say, no, I'm talking about the apple that makes phones. No, it will be like, oh, it can come in silver, gray, black, titanium, whatsoever. Okay, so it is able to understand that, yeah, okay, all of a sudden, we're not talking about Apple the fruit, but Apple the company. So they're very good at understanding context. Like if you give LLMs just the right context, it can become really good. And then they have an innate ability to continuously improve via something called as RLHF, which is nothing but reinforcement learning with human feedback. Like there are humans at the back, and there's reinforcement learning that is happening, which enables, like, yeah, fair enough, you're retrieving more and more most you're so, like, even if the data on the internet gets scarce, you have this data that, like, the insights that we are generating as users of these LLMs, and these LLMs can further improve basis the most important data from those aspects, and they can continue to improve forever. In fact, there's a session on Pathways YouTube. Just go and search pathway.com on YouTube, and you'll find Pathways YouTube there. You'll find a session called as the Future of LLMs. That is taken by Lukasz Kaiser and Jan Chorosky. Lukasz Kaiser is this guy. And Jan Chorosky is the CTO of Pathway. He's also a cool guy. He has worked with the likes of Joshua Bengio, Geoff Hinton. They're like they're three godfathers of AI, if you know. One of them is Jan Lekon, second is Geoff Hinton, third is Joshua Bengio, and Jan Chorosky, the one from Pathway, has co-authored several works with two of them. So that's an interesting session talking about the future of LLMs. You should go and check it out after this session. And then it also gave this ability to LLMs of multitasking and easy prototyping. Like for example, you want to build something. It's not that you'll have to kind of play around with 10 models, see what is working, what is not working. It's like, okay, you've been given a task to make something run. You pick up a powerful model off the shelf, which we also call as foundational model. You pick them off the shelf and just simply run it. You build the application, show that it's running, it's working perfectly, it is solving a business use case, and then you can work on things like optimizing the results or reducing the cost and everything. Okay, so like these kind of things became quite possible, and this brought a paradigm shift in the industry. Like we could now operate with a lot more flexibility. If simply said, okay, interaction became way more simple. When you interact with LLMs, for example, you don't have to give out input in a particular way. It can be an unstructured input also, right? And LLMs are good at understanding it. Like right now, you can upload an entire PDF on ChatGPT Plus, and it can understand it. Now, PDF is basically a collection of images and tables and text. These models are parsing it very well, and you can now deal with a lot of amount of data. You can update these models. Like for example, traditionally, the models, for them to learn continuously was a difficult task. Now with RLHF being very much in place, it becomes like it gives a good pathway in terms of what are the next steps around the future of LLMs. The UX is much better. It has rapidly increased the pace at which we're moving, and also when we say that, yeah, we can work with unstructured inputs from our end, it also means that we can work with multiple types of data sources. Like let's say traditionally we were working with particular set of data sources which would feed or ingest data in a particular format. Now you could work with a lot of data types. And sorry for that ill formatting. I made some last tweaks here, like font changes across the cell, slide, and it broke all of these things. But essentially, if you look at these models, it's simple. This slide basically talks about is that you have these models which are like also multimodal in nature. What is multimodal? Like let's say text is a modality, mode of, let's pick it this way. Let's say text is a mode, so now image can be a mode, videos can be a mode, code can be a mode, audio can be a mode. But multimodal models are like they will have multiple types of these modalities that they can deal with. Multiple types of inputs, multiple type of outputs. Many models are like, many setups are like, okay, they can take multiple types of inputs. Like you can give it an image, you can give it an audio, you can give it a video, you can give it a text, and it will always give the output in a text format. So even that is a multimodal because the input is multimodal in nature. And then there are these models which can do both. Like it can also take images, text, and they can also give out output in multiple formats. So that is where the domain of multimodality comes here. So far, we know that all of this can be done with ChatGPT, right? Um, where does our role fit into this entire picture? Can we make LLM applications any better? or it's like it's quite obsolete. Either you get to Google Brain or DeepMind and the likes of OpenAI, Mistral, or it's over for you. Is it like that, or there is actually some scope for you to make an impact? So the answer is yes, there is a scope for you to make an impact. But before I go there, I want to quickly check if there are any questions here. There are none. By the way, a very quick note: if you are liking this session, please hit the like button so we know that you are liking it. Hit the subscribe button. If you're on Pathways YouTube, you can go and check. And even for CCIT Guwahati, you'll see that the sessions that are there, they're all educational in nature around the interests that you have. So subscribing is naturally a way for you to tell YouTube algorithms that yeah, you want to see more of such content. So do go and hit that button to show your support also and improve your feed. Okay, so how do you make it better? It's simple. By customizing it to your use case. Like you can't, if you come tomorrow and tell to me Mother that, hey, you know what, I want to make a better version of I want to make a better version of GPT 4.0. I want to make a more powerful version of GPT 4.0. Then it'll be like, hey, you're probably being a bit delusional, because it's not about your skills, but it's also about the amount of data you need to have, the insane amount of compute you need to have, and then putting it all together within a given timeline faster than the incumbents. And who are the incumbents? We're talking about Meta, which is Facebook. We're talking about the likes of Google, talking about the likes of OpenAI, Mistral. You know, to beat all of them who have these billions of dollars of funding and somehow manage to get hundreds of millions of dollars to build these models and build it faster than everyone else and sell it. That sounds a bit difficult to do, right? So how can you make it better? You pick these models and apply them in a very smart way to solve a particular use case better than what a generic stuff would do. And how do you customize it? Let's take two examples of so that you get a clarity of what I'm talking about around customization. Let's take the use case of Netflix and second is Amazon. Let's say you are working for Netflix. Okay. And you are the CEO of Netflix. Let me pick a name from here. Let's say you have Anuj or Saksham. Okay. Let's say Anuj is the CEO of Netflix and Saksham is working as a data analyst, let's say. Okay. And in that case, let's look at it this way. Now the CEO of Netflix will be like, you know what? Hey, we have these LLMs that are performing very well. Can I ask them to tell me how the Netflix user adoption is faring in the state of Assam over the past 1 month? How does our retention metrics look in the state of Assam? How many people are sharing passwords in Assam? Let's take it like that example. Now, this is something which is specific to Netflix. This data will change continuously, and obviously, the models like OpenAI do not have access to such internal data. Like they will have access to things like, okay, because Netflix is a publicly traded company, so they might have published certain reports and all those things. It will have access to those reports, but it will not have access to these internal bits. The point that CEO makes, that Anuj will make here, is that, hey, I'm the CEO and LLMs are doing this stuff. Just make it work for me. I think there should be a way to make it work, that these LLMs should be able to answer it for me. It's a simple linguistic use case and basic understanding of things. You're saying it's so good at understanding context. Why can't we just give it the right context and get the answer? That's one option. Second is, like, let's take the example of Amazon. Let's say you're using Amazon. You all of us use Amazon. You're hired by Amazon as a developer to build an engine, a chat-based, kind of option through which Amazon users could find the sneakers that went on a discount over the past 1 week. Okay. Now, again, in this case, if you look at something like GPT, it may be trained on a huge amount of data around which sneakers are cool and all those things. But dude, you're talking about discounts that were released just yesterday, and you want us to, kind of give an output for that using LLMs. How do we make it happen? Now, that's a use case which something like Mistral's foundational models or GPT 4.0 and all those folks cannot solve. What are the common ways that we know of solving these? By the way, we have all completed an analytics boot camp, and we know one way for sure, that is fine tuning, and second is prompt engineering. What is fine tuning? Let's pick that quickly. Okay, fine tuning is basically like, you have a pre-trained model, and you are kind of taking a specialized label data set, a structured data set, and you're refining the weights of the model to perform better for that particular task. Okay. um, but the natural logical thing to think here is that talking about taking a structured, specialized label data set. Now, if you're taking the example of Netflix use case where the model has to give outputs basis various things, or the Amazon use case, for example, where the input is in such different formats, then how do you keep labeling more and more data that is coming in continuously and then fine tune your model continuously on top of it? It's actually impractical in nature. Data preparation takes a lot of time and it's difficult to fine tune a model every single day. In fact, it's very expensive. The much more expensive than RAG, the technique that we are eventually leading towards. If you simply look at the like if you look at something like OpenAI, it has multiple APIs. APIs which enable something like RAG are roughly 70, 80 times cheaper than the APIs of fine tuning. This is just the API cost directly, by the way. So yeah, it's an expensive thing. So challenge the data preparation. Second is cost efficiency. It's not cheap. You also need to have good talent to help you with these things. And then data freshness. You can't fine tune it every single day. So yeah, we know that, okay, fair enough. Fine tuning works well with smaller models, but with something like large language model, we need something else. What about prompt engineering? We heard that prompt engineering is a new big thing, right? Although it's still yet to be seen that companies are hiring prompt engineers at scale. I don't think that is happening right now. But still, we are all using prompt engineering. What is prompt engineering? The input that we give to LLMs is called a prompt. And prompt engineering is like, you're just engineering it to give a relevant input so you get a more relevant output. Basic example from the session itself, if I circle back, I took the example of Apple, right? Where I said, what is the color of Apple? And it said, okay, red, blue, green, red, green, yellow. Instead of that, it can say, I can put the input, and then I said, no, tell me the color of Apple which makes phones. This is what I give as an example, right? Instead of that, if my initial prompt was, tell me what is the color of Apple that makes phones, on the first go itself, it'll give a better output, right? And if I want a better outcome on top of it for a more complex query, a basic point that is noted from this very small example is that if we give a better input, the output will be better. Okay, like give it the right context smartly. And the challenge is when you're putting something, okay, like let's say given the following discounts data, answer this query. Okay, um can you find me discounts this week for Adidas men's shoes? So given that you would have copy pasted data, it will give you that output. But then it's like, the challenge here is, if you copy paste a huge amount of data, it will give you something like this: the message you submitted was too long, please reload the conversation, and blah blah blah. This is because LLMs have something called as a token limit. Whenever you're operating with a very large model, even if the token limit, even if the ability of it to deal with a huge amount of input text is very high, you it's like operating with these very heavy models consume a lot of cost. Point number one. Second is that, yeah, you will hit a threshold in terms of, like right now with most popular models, that how much context can you give. If you copy paste an entire book, it will give you this message that, hey, the message you submitted is too long. And also, if you try to get something which is recent in nature, like the Netflix example, what is the year-on-year revenue growth of Netflix as per its latest report? You say, I am afraid I cannot provide real time or the most current data, blah 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 blah, something like this. Okay, so as I don't have real time browsing capabilities and all those things, so the point being, there are challenges with prompt engineering as well, and then it hallucinates. What is hallucination? Hallucination basically means that, it was in fact the word of the year 2023. It basically means that LLMs are excellent at making up stuff which looks very real, but it is not real. That's a funny thing. That's a problem because it looks real. For example, a very interesting case was, like, if you just checking yesterday, the full form of RAG was said as raising and giving, and it assumed it to be something around fundraising for social causes, and it gave a great description around it, which is absolutely pointless because that is not what it is. It is something else. So LLMs hallucinate. These are challenges. Like, you can't completely rely on that. So what if there's a smarter way to give additional context beyond what LLMs already know? This entire stuff revolves around the domain of RAG. Let me quickly check if we're live. Okay, yeah, we live. No comments. So there's a smarter way to give additional context, and that is where RAG fits into this entire bit. So RAG is nothing but retrieval augmented generation. That, fair enough, it will give the additional context, right? and you're saying token limit is a constant, like you cannot copy paste 100 books, right? So you're like, okay, fair enough, whatever I need to know from the books, I'll just copy paste that bit, not the 100 books. I'll just copy paste what is needed and get the output. And you're saying prompt engineering is problematic because you can't go and manually you can't enter everything, so you want to enter only the most relevant stuff. Fair enough, we'll retrieve the most relevant stuff and just enter that. Okay, so that is where RAG comes into picture. Like, yeah, fair enough, that is possible. So you take something, and this is a cool example. If you look at this GIF here, where Mr. Bean is giving the examination. Okay, now here Mr. Bean needs to give an answer, but they don't have the time to read an entire book. It's an examination going on, right? So what it will do, from the entire set of knowledge that this guy may have, it will just go and retrieve what is important for them. All you need, like, you're not going and covering everything, just the thing that you need. You'll just pick that and you write that out. That's a funny but interesting example to show that retrievers have been there, and RAG has been there in human form every time when we have given an open book examination, ethically or non-ethically. Like, we had some brains of our own. We just retrieve what is irrelevant from a cue card while giving a speech or whatever, and then we gave the output. So the context being, yeah, fair enough, if you can just give the best possible input to the LLM within the token limit, then you will be able to give the answer. But if you are going to give the answer outside of that, then you will be able to give the answer. So retrieval augmented generation. This is a small architecture diagram to show you how this can be possibly implemented. Now you have a data source. This is a small architecture diagram to show you how this can be possibly implemented. Now you have a data source, like this can be static or live, Google Cloud, SQL, like databases and all those things. Relevant information from it, and you give the output. Is talking about one method which talks about vector search. We'll quickly understand what vector search is. That, yeah, well, let's quickly cover what is vector search. Vector search is basically, we're talking about, um, we're saying that, okay, fair enough, we'll convert, okay, I'll describe it, but if it gets overwhelming, you can put it in the comment section and I'll try to answer it. Okay, there's some context that can be possibly introduced before we get to this, but let me know. So I'll give it my best shot. So vector works with numbers, right? It is essentially a mathematical Okay, hi. Sorry. Is it visible now? Let me just check. Dropped off. One second. Can somebody put in the comments section till what point were you able to hear? Because I directly got a notification that I dropped off, so I don't know till where you were able to understand or cover. But I'll just repeat a few elements. Let me know if I'm skipping anything. Ragmeen. Okay, cool. Got it. Thanks, Ayush. And um, so I'll just share my screen. Last 5 minutes. Okay, thanks. Okay, thanks. I'll just share my screen. Okay. Um. Okay. Yep. So we saw this particular meme. We're talking about retrieval augmented generation, right? Trying to understand quickly. And now they can be multiple. We understood that we retrieve the most relevant information. We augment what LLMs already know and get the output. Okay. I'm getting a call. I don't know if it's the IIT Guwahati team, because if there's any network issue at mine. Just give me a second. I'll just check it. Damn, sorry. So sales call, three calls back to back. Like, okay, maybe there's something around in the session itself. Okay, fair enough. So we're talking about retrieving the most important information, right? Now there can be multiple ways. Let's talk about the retrieval case that we know from a long period of time. Let's leave this architecture diagram for a moment. Let's talk about a use case that we know. And I'll talk about something like Google search or Elasticsearch, if you know those cases, right? So these searches have like BM25 is also a very popular um, way to go about the search, where you would search typically basis keywords. Like for example, when you search on Google, right, there are things like you would enter the keyword, and basis the density and all those things, the meaning and everything, it will try to give the best possible output, like how a search algorithm works. Correct. So that's one way that we know. And what do LLMs and RAG does? RAG would go a step beyond that as well. It can say that, okay, fair enough. We know that you can retrieve using the search algorithms, we can using the keywords and all. But is there a better way to understand meanings similar to the way LLMs do? You're like, yeah, there is. Because when I'm talking about LLMs, I'm talking about the model in itself, like this component. Something like ChatGPT. I'll just check, by the way, if I'm live here. Something like ChatGPT or GPT of ChatGPT. Within the model with the transformer architecture, it also works with something called as the vector format, like vector embeddings. What is that? Basically a numerical representation of the text of everything. It's basically like, for example, a map of everything basis the meanings. Okay, like you have a 3D space and arranging everything in it as per the meaning that they have. Like, okay, if apple is here, then it would mean that something like banana would be closer to it in the 3D space, because apple and banana both are fruits and they are similarly, like they have a similar meaning and like similar implication in various cases. Or let's take better example, like king and queen are similar words, so they will be kept together in the map. And the logic being that if you're keeping similar words together, then you can retrieve the most relevant stuff quickly by looking at the nearest stuff around what we are putting as an input. And that is the foundational way in which vectors work. Like, imagine a space, things are kept there basis the meanings they have, and the input that I'm giving, it will just go and see, okay, this is what the person wants, let's look at things near it and retrieve them. That is how vectors work. And this particular architecture diagram is talking about the most common way of implementing RAG, a basic RAG setup, where you're basically having a set of input. What you do is that you convert that into a vector format. That vector format is basically, first of all, you have this huge data, you break them into smaller parts, which is called as chunks, by the way. So you break them into chunks and then you convert them into vectors, and then you index it in such a manner that similar items are grouped together. Okay. At the same time, whenever I as a user give a prompt or a requirement, that is also converted into a vector format. Okay. So what we did, we basically took the input data, broke it into smaller parts, and then stored it in a format that similar items are grouped together. And we did the same, like, because it is put in a numerical format. When we got a prompt from the user, we also converted that into the same numerical format. Why? Because now it's like, if you speak Spanish and I speak Mandarin, we can't talk to each other, right? We need to speak the same language. So this is in the vector format. We'll convert the prompt also in the vector format, and basis that we'll simply make a similarity search. That this is the prompt, this is what the person is looking for. Let's look around and find what are the most relevant stuff. And let's retrieve that. So that retrieval mechanism will retrieve what is important within the token limit. It will augment the context from the backend and will get the answer. For example, let's say a support executive is asking something like, "Hey, I'm a customer support executive. So and explain to me the latest product release that help the how does the latest product release help the customers?" Now, what happens? For example, I'll give you a use case. When you're in the industry, right, developers will release um, product releases every now and then. You use your apps on Play Store, App Store, and all, right? See that new apps keep on coming in. But as a support team, they need to be aware of these things, no? Like, what is the latest thing that we've done? They need to give the most relevant output. How do you do that? It's like, yeah, you can put an LLM to use for it. Just keep your entire product release notes and or whatever it is in this format, convert that into index vector format, and make a search, like use basic RAG, and it will retrieve the output. that, hey, what, basis the latest product release, this is how it helps, blah blah blah. So this is how basic RAG works using vector search. And when we talk about things like, by the way, vector databases and everything, so they are all in this spectrum. Pinecone, VV8, and all, they are basically databases specially built for storing vectors. Okay. Something like Pathway is an in-memory vector store. It means that it's not a database, but it can store vectors within the program memory itself, while ensuring it is quite scalable, and it is extremely good when you have a data source that is dynamic in nature. Otherwise, if you work with other tools, it is extremely complicated. Like, for example, let's pick it this in this way. Like, you have a Google Drive where people are adding documents, and you built a rack system on top of it, like the Netflix example, right? Tell me how my growth, or tell me what is the latest updates from the India meeting, something like that. The Netflix is asking something like that. Okay, now in that case, let's say it retrieves from the Google Drive whatever it has, and then gives the output. But now what happened is, like, let's say Mudit, who's an employee of Pathway, uh, who's an employee of Netflix, updated some particular bit, and he's like, no, this is the wrong information that I updated. Let me go and update it. So they go and delete that information. And now the challenge is that you've already gone ahead and indexed that particular bit in a vector format. How do you go and efficiently remove it from your vector index without making your pipeline or architecture diagram look very, very clunky? Now, if you do it with Pathway, it looks as simple as this, the one we're seeing in front of us right now. That is what it does, an in-memory vector store. And if I circle back to this thing, which is basically the set of tools that we saw earlier, they all fit in some of the spectrum. Like, these are all orchestration tools which either retrieve or they store vectors. And these things, Hugging Faces, Llama 3.1, Mistral, Replicate, OpenAI, Gemini, are all tools which are all LLM providers, basically. Something like Olama and all. Olama is a tool that is used for working with open source models like Llama 3.1, Mistral, and so on and so forth. Google Drive, SharePoint are nothing but data sources that are commonly used. Okay. And I see a comment, by the way, which says that Vector RAG is like 100 years old. Graph RAG by Microsoft is much better. So yes and no. By the way, RAG as a technology is quite new. By the way, it came out around 2020 itself with a paper by Meta folks, and that is one of the reasons why people are still trying to figure out what are the best ways in which you can build RAG systems. Okay, things like Graph RAG and all, they're good works, but they get a lot of buzz also because they are published by a huge maker out there. But using graphs in RAG has been there for a while, and that is something that we'll discuss very soon. But the point being that this technology we need to understand is relatively new. So when you're retrieving most relevant information and giving the output with the help of LLMs, that retrieval part in itself can become much better. It will become much better with time. It's in the process right now. And that's why if you simply implement a basic rack setup like this, many times the output that you may get will not be the ideal output that you want. It may be slightly suboptimal in nature in certain cases. So you can optimize it. So there are ways in which you can take this particular process. One is improve your retrieval gradually. You can start with something like keyword based retrieval, like use BM25, TF-IDF, Elasticsearch, or whatever, and they may do a keyword based search and retrieve like Google search. Okay, or you can have a vector search like the one we saw right now, which is very much deep rooted on the contextual understanding of things, similar to how LLMs work. Or it has something like a graph. Graph is basically like a map of everything around how they're related to each other, then retrieving stuff on top of it, which is where graph rag fits into picture. Okay. Or you can have something like a hybrid index. What does that mean? That means that you're combining multiple techniques, like that you're using vectors and keyword based to find things that are most relevant, improving the accuracy of your retrieval significantly. Typically, when you see the highest accuracy, that is with the hybrid indexes itself. Okay, but you don't need to start from that. I'll show you a few ways in which you can get started after this. You can also use something like re-rankers to improve retrieval or adaptive RAG to reduce costs. There's some very popular and common ways to reduce to improve the outcome of your retrieval mechanisms. Re-rankers is, let's say you retrieve first 10 chunks, 10 outputs, right? That these are the 10 most closest things. then you would again go back and see that out of those 10, which is the most relevant one, basis the input that I'm giving, which basis what the user wants. It will rank them and then try to get an output. It will re-rank them and get a better output retrieved and augmented and then generated. So that is retrieval augmented re-rankers. Adaptive RAG is basically you would retrieve you instead of spending like excess amount of tokens, you will take a recursive approach. You'll see that okay, let's retrieve from these chunks. Are you getting the output? No. Then only we go back to next. We don't go about searching in the entire corpus, something like that. So I'll share a couple of documentations or links that you can go through. It's easy for you to go and read the material on top of these things. So, for example, something like adaptive RAG, which was introduced by Jan Chorosky from Python. Now, by the way, these terms are very interchangeably used in context. So don't go by simply applying them directly. If you're using them, best to cite it and also mention what you're referring to by these terms. Because it's a race where every company is trying to make a path-breaking stuff and requiring terms. You want to be correct as a developer, so you go and cite it where it is coming from. But adaptive RAG, you go and check it. It's like and share the material. It's a way to reduce the cost that you're spending without compromising on accuracy. Re-rankers, on the contrary, is a way to improve the accuracy itself. You can have guardrails also. For example, let's say I am an employee of Pathway and I want to know that tell me the CEO of the salary of the CEO of Pathway. Okay, now obviously as an employee of Pathway, I should not be like many in many cases. You should not be allowed to know the salary of your boss. Tell me the what is the increment of my boss, what is the performance review, and that's something you should not know now. But in a typical RAG setup where you are indexing everything and just giving the output, it'll end up giving it. So no, you can't allow that. You need to have some checks in place that hey, you know what, this should not be given. Or something like PII detection. What is PII? Personally identifiable information. For example, you're implementing this in a use case where people are sharing the personal information. You don't want to index that and give it as an output in contexts which are not correct. So you can have those things. You can also have dynamic updates with data source, as I said. Like with Pathway, you can do it from day zero itself. With something like if you're doing the traditional rack setup, it is way more complicated. But you can gradually move towards that as well. That is a basic. So the entire fuss around dynamic RAG, if you Google it, dynamic RAG is around working with dynamic data sources. So this is something that you can do. So these are some of the things that are like relevant as of now. I hope you got some context around what a RAG is. I'll give you a way in which you can get started with your hands-on journey or around RAG, by the way. So just go to pathway.com. Okay. First thing I would request is that you should like go to the GitHub repos and start them. It really will keep you updated. It will also show your support to Pathway and its frameworks. So these are the two repos. Go ahead and start them. Um, and do explore what it is. Actually, it has a lot of templates as well. Example, LLM app repo is entirely about templates around RAG pipelines, and which are all enterprise driven, which means that they're actually deployed in production settings, and then in many of them we're like, okay, let's go and share it with the community out there. So it is now published in the repos. So when you're looking at something um, and finding it extremely easy, it may be easy, but the fact is that it's also used by companies directly. So it's actually a hope generation kind of thing. Like, yeah, you can also, you don't need to know everything to be able to build something which is very, very powerful. Go to app templates, go to homepage, go to this particular bit, app templates. Here you will find a lot of templates that you can follow step by step to get the output. For example, just open this one. Okay, and you can see like the one which we can run within Docker. Docker is a containerization tool. Very helpful. It will help you avoid problems like it runs on my computer but doesn't run on yours. That can be avoided with Docker, or you can run it with Notebook, Jupyter Notebooks as well. So these all repos, you can run them within Jupyter Notebooks. Example, this one you can go and run it step by step, everything from step 1 to step 10 with a description of what is happening here. These app templates are a way to get started in a seamless format. Okay. That's it. Do you have any other questions that I can answer? What is the pricing model? Okay, I'll answer a few questions here, by the way. Okay. So there is there's a question. What is the pricing model for Pathways multimodal RAG? See, Pathways is an open source framework, so you can pretty much go and use it. There's certain cases which are very enterprise in nature where we try to where there's a license that one may have to opt for. So that's a separate case. But the multimodal drag, you can simply use it. don't need to pay anything for it. If you're using for indexing and retrieval and all, that's a separate thing. I'm not the best person to answer it since I don't come from that side of things. You can, if you're from the enterprise side of things, you're looking to apply that into a use case, then you can reach out to you can reach out to me, or you can reach out to the team at Pathway via contact button on the website, and we'll be happy to help. Honestly, I'm not the best person suited to answer this. um, I don't see any other questions. If you have any questions that I can answer right now. Okay, I'll just go and check on YouTube also, because sometimes on this platform I see things with a second. Okay, I don't see any questions here. So, well, thank you everyone for joining in. I hope this was a helpful session for you. You can drop in, like, you can go to pathway.com, by the way. I'll share one more thing. You can go to pathway.com, and there's an option where you can go and subscribe. I'll do that. So, again, we don't send out any promotional stuff that way. Like, it's educational, developer focused stuff. It's an open source developer framework at the end of the day. You can go and subscribe for the newsletter of Pathway. That will help you stay updated with any key developments that is coming from the side of Pathway for sure. Okay. So for that, you can go to the blog, okay, and just click on subscribe to a newsletter and enter your details. You will be subscribed. You will be getting the email update. That's a way to stay updated. And also, we keep on running these boot camps and free learning resources where you can go and learn RAG in a structured setup. We in fact ran one with IIT Guwahati, concluded one with IIT Kanpur and BHU recently, and with IIT Delhi recently. So yeah, once the next cohort in India is out, you can go and join them for free. All of these are 100% free. We don't charge for any of our educational initiatives. It's the way for us to add value to the community. Anyway, thank you so much, folks. Thanks, Lax. Thank you, Ms. Arun. Thank you, Dhruv. I hope this was useful, and I look forward to seeing you in the next sessions by Pathway and CACIT Guwahati. Thank you, folks. Take care. All the best.